back to Boulder Dash in PICO-8. This is part 10, and before we dive right in and I show you how to animate enemies and the player sprite, let me first show you some improvements that I made off camera. So the first thing I did, and you may have had this in the last file if you downloaded that, our enemies are now organized like this. Every animation frame is 4 apart. So we have an animation for creeping right here, and down is here, and right is left is here, and up is here and here. And the same goes for our other enemies. We have added a few more so that you have some variation in movement, and you can see this in our enemy code. Let me quickly check. So before we only had this code up here to add the bug enemy. Now I added 3 more enemies, which are this square, this orange diamond shaped thing, which in reality is also a square, and my son drew this little, whatever it is, a wolf or a fox, which follows the player. So this enemy just goes left and right. This enemy just goes up and down. This enemy tries to follow the player, and I didn't make it too hard, so you can improve that if you like. And you can also add more sprites and more enemies if you like. So these are just these. So we have these here. They are created by just placing them on the map. And you can see this here. You always place the first animation frame on the map, and the code will then go and create these in our enemy table. And then we have the animation code here, which is this one is for the bug, and then follows the animation code for the up and down variant, the orange one, and the left and right, the blue square. And we have the one that follows the player, which is a little bit more involved, but it's not too complex. So you can check this out if you like. I will not go into detail in this episode. It's just so that you have a little variety of enemies. I also went ahead and created a real level so that it at least plays a little nicer. And you can see here's our enemy, and it follows us around. It's facing the wrong direction, which is not a big problem. And you can see enemies also bounce off of enemies. And we have to do some corrections here so that this looks good again. Let me just finish the level because I want to show you something else. So that was the open door sound. Let's head to the exit. And there's our exit. Here we are. And I added this little end screen with a diamond rain. And you can find this if you open the file in the 6th text file, which is called rain stuff. So if you go over these tabs, you can see the comments or the titles up here. So in the rain stuff, we have an init rain, which is called once, and we have a let it rain when the update function is called, and we have the draw rain function, which is here. And I added some sprites for that, so that, let me check, where did I add these? Exactly here. So this is slime. We haven't had and talked about slime yet, which is another enemy which comes from, I guess, Emerald Mine. And you place one somewhere on the map, and it grows, and it fills the map slowly. We haven't implemented this yet. You can do this if you like. It's a nice little exercise. But I added these here, which is kind of a basin with slime where the diamonds fall in. And if a diamond falls in, it gives this splash, and the code for that is completely in here. And it's called in our init function. It's init rain. We have the when the game is over and we won, we have the let it rain function, and we have the draw rain in the draw function. So these are pretty much the 3 main functions used for this rain effect. So now we have, except for the animations, quite a nice basis for a complete Boulder Dash game with all the quirks and features of the classic Boulder Dash. And yeah, let's add some animation in this episode. And let's start with some simple animation, and we will just do the 2-frame animation of the enemies, which is to iterate from here to here to here to here to here to here, so that it looks a little bit animated. And since all the enemies have their 2 animation frames separated by 4, you can implement this completely different, but the principle applies to all the ways you can do that. What we do is we go into our enemy stuff file. And so the first thing you do is you add these enemy anim, which pretty much says which frame to show of the enemy. And that is, the value in here is added to our standard sprite number one frame. I will show you that in a minute. Then we go, and since I have changed the order of the sprites, we now have to correct the order of the bug sprite again, and direction left is now 20, direction down is now 19, direction right is now 18, and direction up is now 21, which corresponds to these 4 sprites right here. So we have to give it that, so that it can then add the enemy anim, and we will set this to 0 or 4, and we iterate between 0 and 4. And if we have 0, we just use the one that's shown here, and if we add 4, we, for example, add 4 to 21, we get 25. And if we check sprite 25, that is the up sprite, second animation frame. So that's pretty much how this works. In update enemies, down here, we add a call to a function we now implement, which is next anim, which just switches the sprite. And if we go and implement that function, we call this next anim. And we say if enemy anim equals 0, then enemy anim equals 4, and else enemy anim equals 0. So this is pretty much the iteration between the 2 animation frames. And now if we call this, you can see that our blue friend here is animated, but our bug is not. And that is because we have to add the animation frame to the bug. And we go here, and by just showing the right animation frame, this is not enough. We have to add the enemy anim counter, which is 0 or 4, to show the right frame at this time. And we do the same for all the other directions, which is down, left, and up. Let's see. So now our bug is animated, and all the other enemies are too. So this is a very simple way to animate stuff. What we don't have yet is we don't have a fluent motion from one frame or one square on the screen to the other. I will show you how to do this for the player, and you can then try to implement it for the enemy. Let's start right here in our main file 0, and in the update function, after update player 1, we call a method that we will call catch up. We'll get to that in a minute. We need two helper functions, and we put these in our helper file. And for that we need another variable, the first one being t, which stands for time. And we will have an update timer function, which we already have. And what we do is we go in here and we call this, we call this an update. So whenever we call this, we also want to increase t by 1. So this is a global timer for the whole game. So this will continuously run, it will not be reset. And we will always know how long this game is running. And we need this to synchronize the animation frames to the game. Okay, so that is the only change we make here. And then we need a function, and that is a bit more involved. So we call this get anim frame, and this function will return the right sprite from a number of sprites which we give it in form of a table, and we can tell it if we want animation or if we don't. So we give it a table which is all the frames of the animation. So we have a table for our player which holds the animation frames of the player, and we tell it if we want to animate or not, which is true or false. And if we want to do animation, so if do anim is true, like that, then if we don't do this, we return frames 1, which is the first frame in the table. So if we don't have any animation, we do this. If we have animation, we return also a frame, but to get that frame, we need our timer. And what we do is we get the floor of the timer divided by 8. And why this is 8, you will see in a minute, because we're combining the animation with the fluent motion for the player here. And what we do is, if a player moves from here to here, so to the right, what we do is we move the player 1 square or 1 map tile, but at the same moment that the player changes direction or moves in a direction, we also do kind of a back trail. We tell it the player moves 1 field, but it starts here, and we want a fluent motion in single pixels or 2 pixels. And for that we tell it the width of the actual map tile we are going to move, which is 8 pixels right now. And we tell it the moment the player moves here, we increase the position of the player, but we give it a trail of -8. And then step by step we are catching up. That is this catching up method, which then counts down and moves the player pixel by pixel to its new position. And that is why we divide our current timer by 8. And what we do then is we go and we divide this through the number of frames plus 1. If you do the math, you will see that this always returns a valid frame, a frame which cannot be higher or lower than the number of frames in our table. And we have to add 1 because this could be 0, and we don't have a 0 in a table. Tables always start with 1, so we have to add this 1. And that is a very smooth and simple method to get the correct animation frame. We could also count it up or stuff like that, but why? Much easier that way. So that's why we have a global timer. The 8 comes from the 8 pixels width of the map tile, and the number of frames comes from the number of frames we are giving here. So we will use this method in a minute, and that is all we add here in our helper function. So let me quickly go to the player stuff and implement at least the stub here. So we'll just give it an empty function so that we can run the code. You see nothing has changed because we haven't implemented anything yet except for some helper functions. We have to go into player, into our player file where we are actually right now, and we have to add a few more variables to our player one. So what we have is we have player one dot offset x, which is 0, and we have player one dot offset y, which is 0. These are these trailing pixels, which we will use later. We have player one dot score, which we are not using right now, but we will because we have I have some weird stuff where I use the underscore instead of the dot. So let's put that in here for now. We'll not use this in this episode, but we will do in the optimization episode. Then we have the table which contains the animation frames of the player, which we will use at 1, 2, and 3, which are 1, 2, and 3, these 3. The fourth is the idle function, which is used if the player just stands and does nothing. I'm not using this right now, but these are the 3 we are using to if the player is moving. And we have to tell the system if the player is animated or not. If we wouldn't tell our function right here, if the player is animated or not, the player would also do his walking stuff while he's standing, and we don't want that. We only want him to be animated while moving. So we have to add this here. Then we have to add the other directions here, because I will show you in a minute. And then we add some code at a specific place in the can move to. So if a player can move, we now have to add our trailing code here. And so what we do is we say player one dot anim is true. So we want the player to move. And if the left is true, then we say the player wants to move to the left, so we have to trail back positive. So the player wants to move to here, and he is here. So before he can move here, we put the player position here, but we subtract, so we add 5, in terms of the coordinate system, we add 8 pixels so that we can then slowly move him there. And we do the same for the other directions. So we have down, which is minus normally, but we would, since we are going up, he would also add 8. Then we have right, which is minus 8 because player wants to move here, and we have to subtract 8 because that is our back trail, and when we catch up, we go that, like that. And we have the same for the that's wrong. This is up and this is down, like this. We want to go down, which is plus, and we had to subtract 8. Yeah, that's true. Okay, we have that. Now we have to implement 2 things. First, we have to edit our draw player 1 function, and then we have to implement the catch up function. So let's first start here. And what we do here is we have to change this. Now we have a static sprite, which is sprite number 1, and we have the blocky movement. And what we want to do is we want to use the offset and we want to use the animation. So we have to change this to the current frame, which we do by get anim frame of player one dot anim frames. So this tells the function which animation frames are there for the player. And the second thing we do is we tell it to animate or not. And then we go and we do this, and we add player1 dot of x, and then we have player1 y plus map offset y, which is already there, plus player1 dot offset y. 1 is correct, and direction left. Okay, so let's check this. And you can see the player is always moving. It looks a bit funny right now because we haven't done our catch-up function yet, so it's all broken now. So let's go and implement the catch-up function. And the first thing we want to notice is if the player has moved. So has moved. We set this to false, because if it's false we don't have to animate, and if it's true we have to animate. And if player1 dot of x is bigger than 0, then player1 dot of x minus equals 2. So if this back trail offset is bigger than 0, we subtract 2 pixels. So we are trailing along. And we say has moved is true. Else if player1 dot of x is smaller than 0, so we are moving in the other direction, then we want to add to that. Plus equals 2. And again, the player has moved, so we want to animate. That is left and right, and now we have the up and down, which is pretty much the same. Add this here. So if y is greater than 0, y. And finally, if the player has moved, or has not moved, we want to set the player1 dot anim to false, and that should be it. Let's see. So we are still going blocky up and down, but left and right you can see player's right is moving now, and it's only animated if it's moving left and right. But what you can also see is that the map is quite choppy, so we'll have to deal with that in another episode. But as you can see, we have now fluent animation from frame or map tile to map tile, which looks nice. Also works with the rock, but the map is choppy, and because of that it looks a little crazy. So we have to back trail the map also. And up and down we don't have any special animation, so yeah, only animating if it's up and down, left and right. So what we have to do to get this up and down motion is just notice that we only have the B left and B right for the left and right motion, but if we go up and down we don't have that. So what we do is we go here and we say B up is true, and we go here and say B down is true, and that should handle the up-down motion. And now you see it's moving up and down and left and right just fine, which looks really nice. You could implement these backtracking animation for all the other items, but I'm not doing this. This is more of a general introduction to how Boulder Dash works and how to program it, so yeah. So, okay. So I guess this wraps this up for this episode. So let's save this. And as always, you can always download this from the link in the description below. And for the first time, I will also put out the playable version in the browser. So you can export PICO-8 to run in the browser, or the file to run in the browser without having PICO-8. This just creates an HTML file plus a JavaScript file. So to export the file, you type export and let's say rocks.html, and then you get a JS file and an HTML file, and that you can open in your browser and play. And since we are using only the standard keys like X and up, down, left, right, you can also use this or open this on a tablet or a phone, and you can play it on the phone with the controls displayed on the display. Okay, so this now really wraps it up for episode 10. In the next episode, we are going to do some optimizations so that the code will be shorter and probably faster. And we will take a look at what else we can do with this game and what's missing. Levels are missing, of course. So we will come up with a structure for saving and editing levels, because in PICO-8 itself, you can only have one map. So how to get more levels? We will take a look at that in the next episode. Bye for now.
Thank you for watching Retro is the New Black. If you're new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.